Okay, I'm provided a picture. It's of a theme park, and they have a carriage. I do see the carriage. It rapidly moves passengers up and down along a vertical axis, as shown in the figure. It says the carriage is lifted to the top of the tower, then released and moved down the tower. The ride involves 10 controlled bounces from the highest point to the lowest point, and back to the highest point, on and on. So the point X is located on the bottom of the carriage. I do see that in the picture, and it's above the ground in feet. It can be modeled with a periodic function h. So I'm going to say h is a periodic function h. I'm going to say it's a function of time looking at that. So I'm going to say h of t. All right? And let's just take a look what they said. I'm just reading it. It says at time t seconds, x is at its highest point, 120 feet. So I'm going to put an axis down over here. I'm going to say it's starting out at t equals 0. This is time. And t equals 0. This thing up here is 120 feet. All right? So what happens now is at the highest point, 120 feet. At lowest point, is 20 feet. It doesn't say when that occurs, by the way. So I can say 20 feet over here. It's periodic, by the way. And then it goes on to say that, let's keep reading it. The next time it's at its highest point is at 8 seconds. So I'm going to say 8 seconds later, this thing goes like down, hits the ground, and then it bounces back up. And that's one cycle of the curve. Now, as you're kind of looking at that, I'm going to say it looks like a cosine curve to me now. So the first thing I want to do is just talk about the amplitude of it. And the amplitude is going to be, 120 minus 20 divided by 2. And that's going to be 100 divided by 2, which is 50. So I'm going to say 50. And again, I'm going to say cosine curve. I'm hoping I see that in the key when I get there. Let me erase that. I'm going to use my pen. Now I want to talk about the period. And the period is, it's starting at 0 and it's going up to 8. That's how long it takes to do that cycle. And that should be, I'm going to say some multiple b times 8 should actually be the cycle length of a cosine curve, which is 2 pi. So it's going to give me the b would be 2 pi over 8. And this is not shifted at all left or right, which is going to be, looks like pi over 4. So I'm going to say pi over 4 t plus the curve has been shifted up. And looking at it, the shifting up of it, let's see, it's got to be at 120, right? So when t equals 0, you would get 50. Well, 50 plus what would be 120? It would have to be 70. Right, so I'm going to say that's the function. I'm hoping I'm just going to see that. Otherwise, I got to wonder what they did. Right, looking at the k, what do I see? It's not the first one. Looks like the second one, B. Let me just carefully look at that. So h of t would be 50 times cosine pi over 4 t plus 70. You know what? I want to just check a few different things. I want to h of 0 is 120. Again, I'm looking at it. That would be 50 plus 70 is 120. Now h of, the center of this thing would be at 4. So h of 4 should be 20, right? So it's going to be 50 times the cosine of pi. And the cosine of pi is minus 1. And that's going to be 50 plus 70, which is 20. That certainly works out. And then the h of, I said 8, right? That's the end of the cycle. Should be back at 120. What's that going to be? 50 cosine. Well, that would be, let's see, 2 pi. That would be 1. Yeah, 120. Things are working out fine. So I'm going to commit to this answer over here. Thank you.